Hello coders and welcome to another episode of Learn to Code Intermediate. In this video, we will cover the concept of polymorphism and how it can help us write more robust code. As with the other videos in this series, the code that appears will be in C#, but the basic ideas translate to any other programming language. In dry technical terms, polymorphism is the use of a single symbol to represent multiple types. It can be helpful to say that the other way around as well. If multiple different types can be referred to by a single symbol, those different types are polymorphic. This concept can certainly be difficult to wrap our heads around when talked about abstractly, so let's try some real-world analogies. Consider the cookie cutter. You can take a cookie cutter and press it into some flattened cookie dough, and the result is an unbaked cookie. Cookie cutters are quite useful because they allow bakers to create uniform cookies. These are also all cookie cutters. Even though these are definitely different from the previous one and each other, they all share the same common identity of cookie cutters. These different types of cookie cutters are polymorphic because they all share that identity. It is also apparent that uniformity is only a part of why we use cookie cutters. Cookie cutters also come in all sorts of different shapes and sizes. Each of these differently shaped cookie cutters will produce a cookie of corresponding shape. This difference in output between the cookie cutters given the same input is a good real-world example of polymorphism. The same behavior can be observed in the individual keys on a piano. Each key is used in the same way. The piano player strikes them with his or her finger, but each key causes a different note to be played. Because of this polymorphic behavior, by interacting with specific keys in a specific pattern, a player can produce music. One method of implementing polymorphism in code is by using inheritance. Here, we define a base class called CookieCutter that defines a method called cutoutCookie. If you need a refresher on inheritance, please check out our video on that subject. We further introduced three non-abstract classes that inherit the CookieCutter class. Each of these overrides the cutoutCookie method. When we throw together a small example program, we can see how each of these inheriting classes can be referred to by the same symbol. The first thing that the main method does is declare a list of CookieCutter objects. But we are able to populate this list with one instance of each of the inheriting subclasses. When we iterate over the list, each member is called as a cookie cutter, and each member has the cutoutCookie method called on it. As we can see from the output, calling each member the same way gives us a different output. This nifty trick of getting a different output while not changing anything about our main program is polymorphism in action. The same behavior can be achieved via different classes implementing the same interface. Here, we can see the iPianoKey interface requires implementers to expose a play method. We then define four classes that implement the same interface, but return a different value for that same method. Our example program once again begins by creating a list of iPianoKey objects, which can accept instances of each of our implementing types. We can again iterate through the list, referring to each member as an iPianoKey. Calling play on each key also again gives us a different output based on which instance is called. We observe polymorphism in action again, this time through interfaces. In general practice, using interfaces to achieve polymorphism is preferred over inheritance. Polymorphism is usually only concerned with the properties and methods that are exposed by an object, which is very much the strong suit of interfaces. Inheritance and base classes typically carry more complexity, and a good rule of thumb is to use the simplest tool possible to achieve your goals. In the case of polymorphism, that tool would be interfaces. To see how polymorphism can be a useful tool in a more concrete example, let's revisit the cookie cutters again. Polymorphism allows consumers of our objects to achieve different behaviors without knowing anything about our specific implemented classes. To illustrate this in a less abstract way, let's imagine something that can consume our cookie cutter implementations. Suppose we need to create a cookie dispensing machine that should dispense cookies of 3 different shapes. A user can select options 1, 2, or 3 on the machine and receive a star, pig, or snowflake shaped cookie for each respective option. One way we could implement such a machine is to simply have the machine create and contain one of each cutter when the machine itself is created. It preserves a reference to each of these cutters, and when each option is selected on the machine, a call is made to the appropriate cookie cutter. When we write a small program to use our cookie dispenser, we can see that the requirements are met exactly. Pressing each option returns an appropriately shaped cookie. Neat. Creating things in this way works well enough if we only ever need to make a machine with those specific cookies in that specific order. But it is very likely that things might change over time. For instance, what if we needed to change which option dispenses which shape of cookie? If such a change is required, we would have to hop back into the code for our cookie dispenser and swap which cookie cutter gets called for each option. And we would have to do this for every time a change is required. Additionally, if we ever added a new type of cookie cutter and wanted to replace one of the old types, we would again have to jump back into this cookie dispenser code and change it. This is not desirable in general because while the cookies that come out of the dispenser change, the actual behavior of the dispenser, which is when a user presses an option a cookie should be dispensed, does not change. In general, we should code in such a way that only code directly related to requirements should change when those requirements change. This is where polymorphism can come to our rescue. Polymorphism allows us to take in arguments of type cookie cutter when we construct our cookie dispenser. Because anything that implements cookie cutter can be referred to as an instance of cookie cutter, our dispenser doesn't need to know anything about our specific cookie cutter subclasses. The dispenser simply takes in references to cookie cutter instances, stores those references, and calls the cutters when options are selected. We can now modify our example program to pass in instances of each of our different implementations of cookie cutter into our cookie dispenser's constructor. Running this will give us the same output as our previous implementation. But if we eventually need to change the order of our cutters, we can simply change the order that we pass in our arguments. If we need to replace a cookie cutter with a new type of cookie cutter, we can simply create a new instance of that new type and pass it in instead. In this way, we can change the outputs of our cookie dispenser, not by changing the code of cookie dispenser, but rather by changing what we pass into cookie dispenser. This clever trick is known as inversion of control and is made possible by polymorphism. We will review more about the concept of inversion of control in a later video. Now that we can change what our cookie dispenser outputs by changing what we pass in thanks to polymorphism, we can consider even more interesting design choices. The code shown here prompts the user to select 3 different cookie cutters to place in our dispenser. Once the user has selected, we can create a new cookie dispenser with their choices. Here, we can see the output of our new cookie dispenser design. A user can pick which cookie shapes they want to be dispensed and can now create an entirely custom dispenser each time they run the program, all without having to change any code between runs. In this lesson, we covered that polymorphism is the ability to refer to several different implementing types with a single base class or interface symbol. This ability allows us to change our program's behavior by passing in different objects rather than by changing behavior-specific code. We also covered that polymorphic behavior can be achieved via inheritance or by interface implementation, though we should generally prefer interfaces. We also learned that polymorphism unlocks higher level concepts like inversion of control, which can make our designs more flexible and robust. Thanks for watching this Learn to Code video. If you liked this content, please consider hitting the like button and subscribing for future content. See you next time, and happy coding!